That'll be add to the fun. Okay, so who cares about that? Don't look at that third hour. Okay, and then all we did was looked at the front parts of this, and I'm just going to go over it one more time, and then tell you the synthetic division actually helps take care of this long division, which doesn't that look ugly? Let's all just agree. Doesn't that look like an ugly question? All right, and you are going to have to do it next year. Synthetic division, this thing I keep mentioning that you haven't seen yet, can only be done in specific cases anyway. And when we have those cases, we should use it. But um, it can't actually be used in this specific case here. So this question, you would have to long divide no matter what. But just be aware of that. And what is long division? What you did in grade school. In third hour, if you don't remember how to divide with those division garages, I don't know what to tell you. All right. So you can look at that and understand letter C. No, 7 is not a factor of 316 because there's a remainder. All right. That means it didn't go in evenly. And then without knowing about division of binomials, or sorry, of polynomials, I had the wrong word in my head. To see if x minus 7 is a factor of this polynomial, you probably should just factor it and then see if it's one of the factors. Then, yes, it's a factor, right? And that's what the word is for the day. Okay, now, in question 3 in the warm up was an example of polynomial long division. This process will be discussed next year. We'll be using a shortcut method today. And it actually is a really easy day if you just look at the next stuff. Should go very fast and your homework will be lightning quick. You just got to be able to express your answers at the end because you understand what this process is taking the place of. So there we go. Synthetic division can only be used in special case of dividing polynomials by a linear factor. A linear factor is a factor that is an x to the first factor. And the best way that that happens is when the leading coefficient of that factor is 1. This is when synthetic division is good. And then minus some number, minus or plus some number. And that's all you really got to do. Okay, now look at this. Setup of the synthetic division. It's a little weird. And you saw that long division, that nasty question. So this will be done next year, long division, where you're going to have to figure out what do I have to multiply x times to get 2x cubed. By the way, let's start that process. What would I have to multiply x by to get 2x cubed? What's the simple answer to that? 2x squared. So it's not really a big, scary thing. And you know what we would do? We'd put it up above here. And then I'm just going to start what the long division process would look like. What word would describe what I just did with that 2x squared? No time. It starts with a D. Distribute. Okay, so then you put 2x cubed here and then plus 2x squared. What's the next thing that you do in long division? Let's go back up to grade school. What did I do with this 32 right here? What is that operation right there, everybody? Subtract. So in long division, it's actually not shown in that question up there. You subtract. What did I just do with that subtraction sign? Distributed it. Cancel. And then this is negative 5x squared. And then you keep going. Actually, I'm going to do the next part. We have no times for questions on long division. You're going to worry about this next year. So hand down, we got no time. But hey, everyone, what times x equals negative 5x squared? What's the answer to that? Negative 5x. Because what I might do is come back to this question, and then the process continues and show how these first two coefficients happen in synthetic division. Okay, so I'm done. Stop. Don't do this anymore. Next year, blah, blah, blah. But watch. Here's the key to synthetic division. This is step 1. If you're going to long divide by x plus 1, look at what you synthetically divide by. What does that say right there? Negative 1. So really what it is the 0 of this binomial that you're dividing by. So if you're long dividing by x plus 1, it's the same as synthetically dividing by -1. And then notice the coefficients. And one thing in synthetic division you have to worry about is, are there any missing terms? There aren't. You have an x cubed, you have an x squared, you have an x, and you have a constant. Notice those are written in descending order: 2, -3, 4, and 1. This was the x cubed term. This was the x squared term. This was the x, and this is what you would call the constant. You got it? So setup number one for synthetic division, you actually synthetically divide by the zero of the factor, all right, when you set that equal to 0. Now, there is a reason for this. You're just going to have to be memorizing the process, all right? And that's really all I can say about it. Just do it, all right? It's kind of a weird reason why this actually works, but it does. Quick question, what is it? Oh, you're already doing this. Nice. Cool. All right. So, math team already took care of this. So, you should be able to teach this. You learn best by teaching. All right. So, step one, pull down that leading coefficient. That is the beginning point. It's weird, but you just do it. All right. And actually, look at what we're taking the place of, right? I just realized that we're still going with this question. So, remember my first two parts of the answer. All right. Pull down the 2. And then the next part, I forgot that Mr. Stronowski's got this all perfectly lined up here, that I don't have to do a thing. Okay, so here's the weird process. You take this -1, multiply it by 2, put this right here, and add these two. All right, and then look, -5. Remember -5x, part of my answer, right? So you're starting to get the coefficients of the answer from long dividing. And then we stopped after that. Then the next thing is multiply -1 times this. And that ends up being 5. And then you multiply this. And then that ends up being -10. But what does the answer mean? All right. And I forgot to write this in the grade school example. Remember Lexi turning the remainder into a fraction? Do you remember that? Okay. And that's what you have to do at the end for this. And I did say up here, you actually could technically put a plus sign here, 45 plus 1/7. But we just say 45 and 1/7, right? You know what the word and means? It means addition. All right. That's what I want you to understand here at the end with polynomial division. The plus is a must. So notice this answer when I started the long division process: 2x squared minus 5x. This went down a degree, right? We divided an x cubed and now it's an x squared, correct? So in synthetic division, we must realize that this represents now, I like to call this a depressed polynomial because it is called that. The reason is it's a depressed polynomial. It ain't what it used to be, just like Mr. Samuelus. All right. It gets knocked down a degree. All right. And this is x squared, which this now is the x term. This was the x term. This is now the constant. The constant becomes the remainder. Everything gets knocked down a bunch. So that's how you analyze your answer at the end. This is those two polynomials divided. By the way, is x plus 1 a factor of this? Yes or no? No, not a factor. Why? There is a remainder. All right. If the remainder was 0, then it would be a factor. Fumble back there. Hopefully everyone's good on that. Boy, I wish they weren't doing polynomial form. I really hate polynomial form. We have polynomial form with our seniors as well in CAT, and that we kind of left it this year. So we'll worry about that next year. And I'm going to tell the other people as part of this. It goes again. All right. And we'll leave it at that. Okay, so here's how easy it is. Number one, what goes in this blank here? Thanks, Pen. What goes in that blank? -1. All right. And then are we missing any terms? Yes or no? Is it in descending order? Yes or no? We're all good then. 1, -5, -5, 3, -2, draw a line. What's the first step? If you don't do the first step, you screw up the whole thing. Drop the 1. And then you can start the process. Multiply, add, multiply, add, multiply, add. God, I gotta leave. I gotta tell people now this is the worst. Okay, so this ends up being x squared minus 6x plus 9 plus, or you could put minus. I'm going to do plus a negative. Remainder over divisor. Notice I don't put x or negative 11 over negative 1. Negative 1 is x plus 1 in disguise, is what we divided by. So kind of went over that pretty fast on what do we do with the remainder at the end. You should be able to handle it because this process is pretty easy. All right. I think I could skip around here. Let's see. Yeah, let's go to synthetic division when a term is missing. You must account for that. Must. Have to. Okay. First of all, everyone knows you divide by. There you go. Got it. Works every time. Can't wait till I break this pen. I wrote the negative. Did anyone see that? I did. Thank you. All right. And then what term is missing? What term is missing? Which term is missing? Tell me, I'm going crazy up here. The x term. So 2, 5. What do I write next? 0. You're right. And then 9. Okay. If you don't account for missing terms, you enjoy wrong answers. All right. I'll just leave that at that. First step, 2, -6, 3, 3. Ayo! What just happened for the first time in forever? What just happened? No remainder. What does that mean? X plus 3 is a factor. Quick question, hand up. If you ask me, can I go to the bathroom? You're suspended. At this point, I'm in the middle of the notes. I don't have the time for it. Oh, yeah, go ahead. You're killing me, Smalls. Now you have to tell me what is missing. What is missing? Which term? Which term is missing? You have an x cubed, you have an x squared, you're missing the x term. So you must account for that missing term. We did say that a few times. X cubed, x squared, you must think of this as that being there. You must have all your positions taken care of for synthetic division to work. All right? Do I have to do this one? Yeah, let's do it. Which term is missing, everybody? The x to the what term? Did you hear that? All right. Which term is missing, everybody? X to the third. So what do I do about it? I put a what there? 0. Okay, so let me just make sure. 1, 2, 0 for the x to the third. Wait a minute. I'm completely wrong. What else is missing? X squared. I don't have an x cubed. And then I don't have an x squared. So I got to move this over even more. Ooh, this is a big one. All right. And then -5 and then -14. Freaking out, man. There's too many things I got to do. Oh, bring down to 1 and then your multiply add process. 0, 0. Well, this is interesting. 0. I don't want to make sure I'm going too fast here. -2 plus 2 is 0. Then 0 times -2, 0, 0, 0. Now we got something. Oh, is this a factor? Yes or no? No. Now, what is the final answer? Actually, not bad to write. I always do this for myself. It was an x to the 5th. What is it now? It's a depressed polynomial. Why? It's not what it used to be. It's now an x to the what? 4th. And then no x cubed, no x squared, no x. and that's the constant. And then that's the remainder. The only way I can get my pen to work. Okay, so notice all the missing terms that are over and done with there. All those zeros, we don't have to write them. You don't have to write 0x cubed, 0x squared, 0x. Just keep things in order there. All right, let's see what else we got here. Determine if this is a factor. And is that it? There's another fumble. Okay. Determine if this is a factor or not. What should I get as a remainder, everybody? No, what should I get as a remainder if it's a factor? 0. Okay, and that's what should happen. So 2. All right, do I have a missing term? All right, do I have a missing term? Yes or no? Yes. 1x cubed, 0x squared, 3x minus 4. So we're still going to go through the synthetic division process, but we're going to say yes, it's a factor, or no. We don't have to write a final answer. All right, so bringing down to 1, 2 times 1 is 2. 2 times 2 is 4. This is going horribly wrong because what's 2 times 7? 14. You don't even have to continue. What do we say? Is it a factor or not? Not a factor. This does not go into that one evenly if this is taking the place of long division, which it is. All right? Oh, no. Fractions? What a jerk, Mr. Samuelus. By the way, what comes in this here? What goes in there? 3 halves, not negative 3 halves. So get the first step correct. 2, negative 3, negative 2, 3. Zip. Bring down the 2. This does make me sad, people that can't do this. What is simply 2 times 3 halves? 3. The 2's cancel. Makes me sad, the fractions and the lack of ability of basic fraction stuff. What's 3 halves times 0, which is nice? 0. Nothing really fractionally hard happened so far. What's 3 halves times negative 2? Negative 3. Boom shakalaka. What do we say about this? Yes, it's a factor. Okay, I'm done as I take care of my life business that I got to do. Sorry I missed you third hour. Hope you enjoy this video.